Welcome back. In the second half of this lecture, we're going to look at some more complicated problems involving trig functions. A couple of things just as far as notation goes. Reminder that if we're talking about powers of trig functions like tangent of x whole thing squared, normally we would write that as tangent squared x. And similarly, if you wrote secant cubed x, that means that the secant function, the whole thing, is being cubed. However, if you see something like this, tangent x squared, then in that case it's only the x that's being squared, only the input. And the other reminder, of course, is that the one exception to this notation about something being a power would be the inverse function. So reminder that when you see something like tan with a -1, that's not tangent to the power of -1, it's the inverse of the tangent function. So if we're thinking about solving this equation, remember that the whole plan is to start out with isolating your trig function. And if I start out with this, tangent of x is equal to 1, tangent squared x, rather, is equal to 1, then I'm going to actually have two different equations that come out of this, because if you're thinking about tangent squared being equal to a number, then tangent of x is equal to plus or minus the root of that number. In other words, tangent of x is plus or minus 1. So actually there are going to be two equations that we need to solve here. One of them would be looking for the solutions for where is tangent of x equal to 1. The other would be looking for solutions for where tangent of x is equal to -1. And these are not too difficult for us to find. For the first one, where is tangent of x equal to 1, that would be looking for x to be tangent inverse of 1. And if you're thinking about your special triangle for the 45, 45, 90 triangle, pi over 4, pi over 4, pi over 2, you know that tangent of pi over 4 is 1 over 1, which is just 1. So you do find one solution using your inverse trig function, which is pi over 4. And similarly, for tangent of x being equal to -1, you come up with the solution of negative pi over 4. Tangent of negative pi over 4 is -1. Now, again, once we've come up with these values, we're not finished. We still need to think about the interval of solutions that we're looking at and how do our numbers fit into it. We're looking to solve over the interval from 0 to 2 pi, so we're looking at all the values within one full revolution, and we're looking for tangent to be equal to +1 or -1. And we know that there's two quadrants where tangent is positive, quadrants 1 and 3, and there's two quadrants where tangent is negative, quadrants 2 and 4. And the one thing that we know is that all of these angles, they're all going to have the same reference angle of pi over 4. So the ones that give us a positive value for tangent, those have a reference angle of pi over 4. The ones that give us a negative value for tangent, those also have a reference angle of pi over 4. So although we found these two values, the actual solutions for our equation would be the angles that have reference angles of pi over 4, which includes pi over 4. It includes 3 pi over 4. It also includes 5 pi over 4. And it also includes 7 pi over 4. Those are all the angles where the reference angle is pi over 4. So for these angles, we have that two of them make tangent have a value of +1, and those would be the values of pi over 4 and 5 pi over 4. And there's two values where Tangent has a value of -1. That's at 3 pi over 4 and 7 pi over 4. So there we go. These are all the solutions for this trig equation. Just like how we did when we were solving inverse trig equations, we might have to do a substitution. So if you had something like a sine of 3x, then maybe you might want to substitute letting u be equal to 3x. So very much the same way that we solved those inverse trig equations. But the other thing that we'll need to remember, just like we did when we solved inverse trig equations, was that we're going to need to go back and find our solutions in terms of the original variable. So if we did a little substitution, letting u be 3x, and we solved for u, then we're going to need to go back and solve for what is x. And don't forget, of course, that when you're changing your variable from 3x to u, or from x minus pi over 3 to u, that's going to change the interval of solutions. So we do have to be a little bit cautious here if we're doing our substitutions. So for something like this, we're looking to solve sine of 3x equal to 1/2 on that interval from 0 to 2 pi. And I'm going to do a little bit of a substitution here to make my life easy. I'm going to say let u be 3x. So really we're solving sine of u equal to 1/2. Except we're no longer going to be solving on the interval from 0 to 2 pi. If u is equal to 3x, then that means that 1/3 u is equal to x. So just rewriting that equation, 1/3 u is equal to x. So that means that instead of saying 0 is less than or equal to x is less than or equal to 2 pi, you could say 0 is less than or equal to 1/3 u is less than or equal to 2 pi. And then you could multiply everybody by 3 to get rid of that third. And that means that what you would actually have for your values of u would be that u is between 0 and 6 pi. So in other words, if x is going from 0 to 2 pi, then u, since it's going to be 3 times whatever the x value is, has to go from 0, 3 times 0 is 0, up to 6 pi. 3 times 2 pi is 6 pi. So that means that when we're finding our solution for u, we're not just going to find them within 1 full revolution. We need to find all the solutions within 3 full revolutions. Okay, so let's start off with this. We're looking for sine of u being equal to 1/2. So we know that sine inverse of 1/2 is equal to u. And that definitely does have a solution. If you're using your special triangles, you'll find that using the 30, 60, 90 triangle, the pi over 6, pi over 3, pi over 2 triangle, you'll find that sine of pi over 6 is equal to 1/2. So you know that u should be equal to sine inverse of 1/2, which is pi over 6. So we came up with one value for u. We also know that sine of u needs to be positive 1/2, and there's 2 places where sine is positive. One of them is in quadrant 1, and the other one is in quadrant 2. So that means that another angle, in addition to pi over 6, would be an angle in quadrant 2 that has that same reference angle of pi over 6. That would be the angle 5 pi over 6. So we have 2 solutions so far. U is pi over 6 or 5 pi over 6. And those are the values within 1 full revolution. Now, of course, we're looking at all the values within 3 full revolutions. So in addition to pi over 6, you could also have 2 pi plus pi over 6, which is the same thing as 13 pi over 6. You could also have, just in the same way that you had 5 pi over 6 as one of the angles, you could also have a full revolution plus 5 pi over 6, which is 17 pi over 6. And then we could say the same thing about 2 full revolutions, that instead of pi over 6, you could have 2 full revolutions, which is 4 pi plus pi over 6, which is 25 pi over 6. And finally, instead of 5 pi over 6, you could also have 2 full revolutions, 4 pi plus 5 pi over 6, which is 29 pi over 6. So we found all the values for u. Now we're not finished though. Even though it feels like we've done so much work here, we still have to go back and solve the original equation, which is in terms of x. So here's where we go backwards and say, well, we now know the values for u, and since u is the same thing as 3x, then 3x is equal to pi over 6, 5 pi over 6, 13 pi over 6, 17 pi over 6, 25 pi over 6, and 29 pi over 6. And solving for x, we just need to divide everybody by 3. So x is pi over 18, 5 pi over 18, 13 pi over 18, 17 pi over 18, 25 pi over 18, and 29 pi over 18. So our solution set here contains 6 different solutions. And let's just write those solutions in our solution set. 17 pi over 18, 25 pi over 18, and 29 pi over 18. All right, let's do another one here. This one, a little bit more of a transformation happening with this cosine function. I'm going to start off by, again, simplifying my life here by doing a little substitution to say that we want to replace u with 3x plus pi over 2. And we are going to have to do the same sort of thing that we did before, which is to figure out what would that do to our interval of solutions. So if we're going to think about replacing the 3x plus pi over 2 with u, that means, solving for x just for a minute here, I'm not simplifying that fraction because the whole point of this is I'm using this to figure out how this will change my interval of solutions, so I'm not going to bother trying to make this into a simpler expression. I'm going to say that since we want 0 to be less than or equal to x to be less than or equal to 2 pi, and since x is equal to that expression, then 0 will need to be less than or equal to that expression, less than or equal to 2 pi. If I multiply everybody by 3, then add pi over 2 to all sides of this inequality, then I have my interval that I need to solve over is over that interval from 13 pi over 2 down to pi over 2. So that's what we're going to be solving here. We're going to start out by saying that what we actually have now is 2 cosine of u plus root 3 equals to 0, and that's on the interval pi over 2 less than or equal to u less than or equal to 13 pi over 2. And that's how we're going to do our solving. So we'll do the same thing that we normally do, which is isolate our trig function. And if I do that, if I bring that cosine over here and move the root 3 to the other side and solve, I find cosine is negative root 3 over 2. And so now all I need to do is think about solving for u. And then once I find what u is, then I'll need to go back and figure out what is x. So let's start with this. We're looking for cosine of u to be negative root 3 over 2. And again, if you're thinking in terms of your special triangles, in particular the 30, 60, 90 triangle, the pi over 6, pi over 3, pi over 2 triangle, you know that cosine of pi over 6 would be adjacent over hypotenuse, would be root 3 over 2. And since we're looking for cosine to be negative, well, we're going to have a reference angle of pi over 6, but we'll need to be in a quadrant where cosine is negative. So what we're going to need to do then is to think about where are all the places where cosine is negative, and then we're also going to have to think about through the interval of solutions that it's not just going to be from 0 to 2 pi, but rather we're going to be looking for the solutions from pi over 2 to 13 pi over 2. So I'll start with this. If we're thinking just in terms of from 0 to pi over 2, we know that there's 2 quadrants where cosine would be negative, and that would be in quadrant 2 and in quadrant 3. So what are some values for what is cosine being negative root 3 over 2? Well, one of them in quadrant 2 has a reference angle of pi over 6, so that's 5 pi over 6. The other one would be in quadrant 3 with a reference angle of pi over 6, which is 7 pi over 6. So when I'm thinking about solving this equation, cosine of u is equal to negative root 3 over 2, we can find out that there's actually 2 solutions that we can find right away, which is 5 pi over 6 and also 7 pi over 6. Now again, we're thinking not just about the solutions from 0 to 2 pi, we're thinking about the solutions from pi over 2 to 13 pi over 2. So that's from within pi over 2 to 13 pi over 2, 3 full circles plus pi over 2. So we're going to have to think of those 2 angles, 5 pi over 6 and 7 pi over 6, and figure out who else is coterminal to those angles within our interval. So if you're thinking about the 5 pi over 6 just for a moment, we had 5 pi over 6, but you would also have 1 full circle, which is 2 pi, plus pi over 6. So that would be 17 pi over 6. You would also have, if we wanted to do 5 pi over 6, we had a full circle plus 5 pi over 6. You can also have 2 full circles, which is 2 pi, plus 5 pi over 6, which is 29 pi over 6. If you did 3 full circles and added 5 pi over 6, you would have gone beyond our interval, because remember, our interval was up to 13 pi over 2, which is 3 full circles plus pi over 2. 3 full circles plus 5 pi over 6 is a little bit beyond our interval, so that means that's all that we have for the angles that are coterminal to 5 pi over 6. Now for the ones that are coterminal to 7 pi over 6. So that would be, we have 7 pi over 6. We could also have a full circle plus 7 pi over 6, which is 19 pi over 6. You could also have 2 full circles plus 7 pi over 6, which is 31 pi over 6. So now we've got all the possible values for u that are within that interval. And again, just reminding ourselves that that interval was from pi over 2 all the way up to 13 pi over 2, 3 full revolutions plus pi over 2. And we found all of the angles that would give us our solutions in that interval. If we went another full circle beyond this, or another full circle beyond this, we would be outside of our interval. If we tried to go backwards a full circle, we would wind up with a negative angle, which again is not inside of our interval. So there's only 6 values for u that we find in this interval. And now that we have our values for u, we get to go back and figure out our values for x. Because remember that u is equal to 3x plus pi over 2. So that means that 3x plus pi over 2 is equal to all these numbers. 5 pi over 6, 7 pi over 6, 17 pi over 6, 19 pi over 6, 29 pi over 6, and 31 pi over 6. And now to solve for x, we simply need to isolate x. We just need to subtract pi over 2 from everybody and then divide everybody by 3. So first I'm going to subtract pi over 2 from everybody. So 3x is equal to, we have 2 pi over 6, 4 pi over 6, 14 pi over 6, 16 pi over 6, 26 pi over 6, and 28 pi over 6. There we go. And then finally, to solve for x, we're just dividing everybody by 3. And when I do that, I'm also going to simplify all of my fractions. So I would have x being 2 pi over 18, which is pi over 9. 4 pi over 18, which is 2 pi over 9. 14 pi over 18, which is 7 pi over 9. 16 pi over 18, which is 8 pi over 9. 26 pi over 18, which is 13 pi over 9. And 28 pi over 18, which is 14 pi over 9. There we go. And there we have our 6 solutions to this equation. So the equation that we have, the solutions on that interval from 0 to 2 pi are these 6 solutions that I have down below.